So up to now, we've been making use of differentiation to move from one variable to the next. I hope that intuitively you would realize that we can do the reverse by using integration. So integrating helps us to move from acceleration to velocity, from velocity through to displacement. To do so, you are going to need a small bit of information, usually information about what the particle was doing when t equals 0. Either its displacement, its velocity, or its acceleration. That's going to help us to find the unknowns. So here we have the velocity function. The first thing I'm going to do is to factorize so I can get an idea of what this function looks like in graph form. So factorizing, I get roots t equals a half and t equals 4. So the questions asked us to calculate the distance that's traveled in between 0 and 3 seconds. So this is the area that I want to collect. I'm hoping that already looking at this graph, you can anticipate what we need to do. We're going to integrate to find this area, but we cannot integrate this in one calculation. We cannot integrate over any crossing of the x-axis. The reason is that the area in between 0 and a half will be positive, but the area in between half and 3 is actually going to end up being negative. If we try to work this out all at once, we're going to end up with that positive area subtract the negative area. We want to combine these. We want to add them together. So we actually need to integrate twice. Once for each side of the x-axis. So I'm going to integrate in between 0 and a half, and then I'm going to integrate in between half and 3. The reason I'm going to subtract is because I know that I'm going to get a negative gradient in between 2 and 3. So actually, if I subtract right now, this as one calculation is going to end up adding the positive version on. So here we substitute in a half, and I get this expression. Substituting in 0 is just going to give us 0. This time around, I'm going to substitute in 3 to these 3 terms, and subtract 1/2 substituted into these 3 terms. A lot of this is just going to go into the calculator, and that gives us an answer of 149/12. So that will be the total distance that's been covered in the first 3 seconds. In this question, we're told that a particle is moving on the x-axis at time t equals 0, so at the beginning of the journey, at the beginning of our observation, the particle is on the point where x equals 5. Okay, so the starting point is where x equals 5. The velocity of the particle at the time t is given by the function 6t minus t squared, and we're asked to find an expression for the displacement of the particle at time t seconds. Okay, so let's just start with the function that we have. This is the velocity function. If we want to find the displacement, we're going to need to integrate. So integrating that velocity function, 3t squared minus a third t cubed plus a constant of integration. We've been given some information. We were told that when t equals 0, x is going to have a value of 5. So if this is the function that helps us to find the x value, we need to substitute t equals 0 and x equals 5. Substituting gives us c equals 5, and now I can just put this into the previous equation, and this is the definitive equation that I can use for the x value. Anytime I want to find the x value, I can substitute a value of t into this, and it tells me the x value it would have on that straight line ruler. Part B wants us to find the distance of the particle from its starting point when t equals 6. A sketch of this will reveal that we have roots at 0 and at 6, so there will be no crossing of the x-axis in between 0 and 6. So we should be safe to integrate in between them. Since we have this equation, we can substitute into it to find the x value when t equals 6. And just reaching for the calculator, we get 41. So when t equals 6, the x value that the particle has reached is 41. Well, the distance travelled is not 41 because this particle started on 5 on the x-axis. So we know that the particle is now at 41 on the x-axis, but it started at 5 on the x-axis. So the distance it's travelled is the difference between the two. 41 subtract 5, and that gets us 36. 36 meters have been travelled since the start of this particle's journey.